Today's lesson is on air pressure, and I'm going to try to keep this lesson fairly short. And in class, we're going to do lots of fun little demonstrations of air pressure. Even though I'm going to try to keep it short, air pressure is very important. It's probably about the most important thing that meteorologists need to know to forecast the weather. And we'll talk a little bit about that at the end of this. We've talked a little bit about pressure in our physics unit, but air pressure is just the weight of the column of air above something. Okay, and that air is pushing down. So air does weigh something, and it's pushing down. You see in this picture here, you have a column of air, and it's going to be pushing down on you and everything else. How much does it push down? Well, it pushes down quite a bit. At sea level, there's about 14.7 pounds per square inch of pressure from that pushing down. For the average person, if you kind of think about the square inches of an average person, it comes out to about 20,000 pounds of pressure trying to squeeze you, trying to crush you. Well, why don't you get crushed if you have 20,000 pounds of pressure pushing in on you? We learned that back in the physics unit. Remember, you have fluids inside your body that are also pushing out. Okay, so we have internal fluids pressure, internal fluids that are pushing out equally to combat this air pressure. Okay, so that's basically what air pressure is. It's the weight of air that's pushing down on you. And we'll do a little demonstration with the Magdeburg hemisphere in class to show you how much air weighs, and then show you how much that pressure would be. Well, how do we measure pressure? We measure pressure with a barometer. And there are two main types of barometers, Mercury barometers and Aneroid barometers. And we're going to start by drawing the oldest type. So it's a Mercury barometer. This was invented by a guy named Evangelista Torricelli, an Italian. I think it was 1644 when he created his aneroid or his mercury barometer. It was actually the great Galileo who suggested that he use mercury in it. Anyways, what Torricelli did is he had a dish. Okay, so here's a dish. And that dish, in that dish, he put mercury. He chose mercury because it was the densest liquid that he could find, something kind of a mercury color here. Okay, so this dish is filled with mercury, okay, the densest liquid that he could find. He then also had a glass tube. Think of it kind of like a test tube. So he had a glass test tube. Pretty long, okay, I think his first one was about 4 feet long or so. Doesn't really matter. It matters how long it is, but not that at this point. So he took this tube and he filled the tube with mercury also, and then he inverted it. So he had a tube, a glass tube, okay, that he also filled with mercury. Okay, so it was filled with mercury, filled to the very, 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 very top. Okay, completely filled with mercury. And then what he did is he inverted this tube into the dish of mercury. What that means is he flipped it upside down. So he took it and he quickly flipped it upside down. So now our tube is flipped upside down in the dish of mercury. When he did that, he noticed that the mercury level dropped a little bit. So it left a little bit of a vacuum at the top. Okay, so this is all filled with mercury. And this is all filled with mercury. So up here, there's a little bit of a vacuum, okay, where there's nothing, no air, no nothing. And then what he did is he watched this barometer, and he noticed some things happen to this level. He noticed that sometimes the level of the mercury went lower. So sometimes the mercury level went lower like this. Okay? When it went lower, he noticed that it was bad weather outside. So when there's bad weather, the mercury level in the tube dropped lower. So he called that low pressure, which we found was bad weather. Okay, so low pressure he found meant bad weather. Well, what would cause the mercury level to drop? Well, it's if there wasn't as much air pushing down. So if there was less air pushing down, okay, so I'm going to draw some arrows up, the mercury in the tube could flow out and into the dish. So it would rise in the dish and flow out. Now, he also found on some days that the mercury in the tube went higher. So say the mercury level was way up here. Okay, so sometimes the mercury in the tube went higher. So he called that high pressure. And it was clear or good weather, he noticed, when the mercury went higher. Now, why did the mercury go higher? It's because there was more air pressure outside. There was more air pushing down on the mercury in the dish, which caused some of the mercury to go up into the tube and raise the level of the mercury there. Yeah, so he found that he could basically predict the weather by just watching the mercury level go up or down. Like I said, if it went lower, it was bad weather. We call that low pressure. And if it went higher, that was high pressure. And it works really well. So these mercury barometers work very well. Basically, average pressure, okay, so kind of average here, would be 29.92 inches tall. 29.92 inches tall, okay, inches of mercury. So you have to have a pretty high tube. Again, so you're talking at least a 3-foot tube of mercury. Well, mercury is not a very safe thing to have around. So we have a little safer version of a barometer that we can use. And that's the aneroid barometer. Aneroid barometers are pretty simple too. So mercury barometers are pretty simple. It's just basically a tube of mercury. Aneroid barometers are really simple too. Basically, you have a can, a metal can or canister. So there's my metal can. And it has a couple of crinkles in it maybe. But all the air, or at least some of the air, is sucked out of my tube, my can. So it's a can with not much air in it. If there is high pressure outside, what's the can going to do? Let me get my same color that we had before. There's a purple. So if there's high pressure, that can is going to crush in a little bit because there's more pressure on it. If there's low pressure, what's it going to do? It's going to expand out a little bit. So basically by watching this can, and we can attach a dial to it, you'll see pictures on the next slide, but by watching this can, whether it expands or crushes, that will tell us the pressure as well. So we'll look at some pictures. Here's a picture of the mercury barometer, okay, like I tried to draw. There's a little vacuum up here. The mercury is filling the tube and filling the dish. When it went down, he noticed that it was bad weather. When it went up, it was good weather. If you want to do the same thing out of water, you need a tube about 30 feet high because water isn't as dense. Okay, so very simple. The mercury rises or falls based on how much air is pushing down outside. Here's some pictures of the aneroid barometer. I like this little picture, kind of similar to the one I drew. So you're going to just attach a dial to it. So again, if it's high pressure, the can is going to crush in, which will turn the dial, okay, and make it higher pressure. If it's low pressure, the can will expand outward. The dial will turn, signifying that. There's also ones that have a tube. This metal can here is curled. So then it will kind of rotate. So as it expands and contracts with the pressure, it'll rotate and turn a dial. So that's a common one too. And these can be tiny. Okay, don't think this is a big canister. It can be a really small one. A couple inches tall is plenty big for an aneroid barometer. And really, some people have, altimeters in their watches. Basically, they just have a little one of these barometers in their watches because you can tell altitude with a barometer because it's just measuring air pressure. So what happens with altitude and air pressure? I just kind of mentioned. The higher you go, the lower the pressure because there's less air above pushing down. Okay, you think if I'm down here, I have all this air pushing down on me. But if I'm up here at the top of the mountain, I have less air pushing down on me. Okay, so the higher you go, the lower the pressure because there's less air above pushing down. That's what I said. You can use one of these barometers as an altimeter. So if you're wearing a watch that has an altimeter, a little barometer inside, there's less air pushing down, you'll read a higher altitude. We're going to do some pictures, some demonstrations. Why I have a blank slide there. So why do your ears pop with altitude change? Again, we already talked about this during our physics unit. I can go over it really quickly, and I have the explanation here if you want to see it. But basically, so here's my mountain. Down at the bottom of the mountain, here's me. Okay. Pressure outside my eardrum and inside my eardrum is equal. Okay, because I'm chewing gum, popping my ears. If I climb up the mountain, the pressure outside now is low because there's less air above pushing down. Inside my head, though, I still have the high pressure from down here. So that high pressure is going to push out. Okay, it's going to try to push out around my eardrum like that, and my ears will pop outward. Okay, and again, hopefully it doesn't rupture your eardrum. Hopefully you chew gum, move your jaw, open that little gap there, and let the pressure escape. So I'm up at the high altitude. I've chewed my gum. I've moved my jaw. So now the pressure inside my head is equal to the pressure outside. But now I climb down the mountain. The pressure outside got higher because there's more air above pushing down. But inside my head is still the low pressure from above. So the high pressure air tries to push in to get to low pressure. So now the high pressure is going in, and again, you chew gum or whatever, so it goes around the top of your eardrum there so it doesn't pop your eardrum. Okay, and I have the explanation here, big long explanation, same one that we saw during our other unit. So if you remember it, you're good with that. Okay, so kind of the last thing is maybe the important thing for our weather unit, and that's air pressure and weather. And we saw with Torricelli's barometer that when it was high pressure, it was good weather or clear weather. Okay, so high pressure is going to be good weather. Low pressure is bad weather. High pressure, good weather. Low pressure, bad weather. Why? Okay. Think about it. If you're on the ground here and it's high pressure, what it means is there's lots of air pushing down on you. Okay, that is literally what the air is doing. The air is falling. Okay, so the air is falling on top of you, putting lots of pressure. And what happens when air goes down is it warms up and air expands, which means the water vapor in it won't condense, so you don't get any clouds. So it's going to be sunny. On the other hand, if there's lower pressure, the air is rising. Okay, and if air rises, as air rises up in altitude, the temperature gets colder with altitude. Cold air can't hold as much water vapor, so the water vapor is going to condense out and form clouds and rain. So low pressure is air rising, which means the water vapor will condense because the air can't hold the moisture. Okay, so this is the key thing, okay, for this unit. So really we can tell if it's going to be rainy or not, really mainly just based on the pressure. So it's a really important thing. Then kind of last thing is, again, dealing with this. So when you look at a weather map and you see H's and L's on the weather map, that stands for high and low pressure. Okay, it's not temperature. H's, high pressure. L's, low pressure. We know air is going to want to go from where to where. It always goes from high to low. So the air is going to try to flow from high pressure to low pressure. Remember, the Earth is spinning, so Coriolis won't let it go straight. But it wants to go straight from high to low. So that makes wind. Okay, air moving from high to low pressure is going to be wind. So the bigger the pressure difference, the windier it's going to be. On a weather map, you see these H's. These lines that go around them are called isobars, lines of equal pressure. Remember, a bar is for pressure. Iso is same, so lines of equal pressure. They're like contour lines you learned about last year with maps. Contour lines were lines of equal elevation. These are lines of equal pressure. See that H for high pressure, 1028, or maybe I should have mentioned this before. We said in English system, normal pressure was 29.92 inches of mercury. So inches of mercury. I forgot to tell you what it was when we did the aneroid barometer, what it was in the metric system. So in the metric system, normal atmospheric pressure is 1,013 millibars. Okay, so this is normal. English system and metric system. 29.92 inches or 1,013 millibars. So we look at this number, 1028. Oh, that's higher than 1,013. It's high pressure. The low pressure here, you see, oh, 1,004. 1,004 is less than 1,013, so it's low pressure. What kind of weather is it going to be if it's low pressure here? It's going to be rainy. Okay, bad weather. High pressure is going to be clear or good weather. Air is rising up. Low pressure, air is falling for high pressure. Air is rising for low pressure. Rises up, condenses, makes clouds and rain. Okay, that's it for pressure.